The braking system is the most important system in your car. If your brakes fail, the result can be disastrous. Brakes are actually energy conversion devices, which convert the kinetic energy of your vehicle into thermal energy. When you step on the brakes, you command a stopping force 10 times as powerful as the force that puts the car in motion. The braking system can exert thousands of pounds of pressure on each of the 4 brakes. In modern systems, the master cylinder is power assisted by the engine. All newer cars have dual systems, with 2 wheels brakes operated by each subsystem. That way, if one subsystem fails, the other can provide reasonably adequate braking power. Safety systems like this make modern brakes more complex, but also much safer than earlier braking systems. The brake system is composed of the following basic components: the master cylinder, which is located under the hood, and is directly connected to the brake pedal, converts your foot's mechanical pressure into hydraulic pressure. Steel brake lines and flexible brake hoses connect the master cylinder to the slave cylinders located at each wheel. Brake fluid, specially designed to work in extreme conditions, fills the system. Shoes and pads are pushed by the slave cylinders to contact the drums and rotors, thus causing drag, which slows the car. In recent years, brakes have changed greatly in design. Disc brakes, used for years for front-wheel applications, are fast replacing drum brakes on the rear wheels of modern cars. This is generally due to their simpler design, lighter weight, and better braking performance. The greatest advantage of disc brakes is that they provide significantly better resistance to brake fade compared to drum-type braking systems. Brake fade is a temporary condition caused by high temperatures generated by repeated hard braking. It occurs when the pads or shoes glaze due to the great pressure and heat of hard use. Once they cool, the condition subsides. Disc brakes allow greater air ventilation compared to drum brakes. Drum brakes are not internally ventilated because if they were, water could accumulate in them. Disc brakes can rapidly fling off any water that they are exposed to, and so they can be well ventilated. Boosters are present in power brake systems, and use the engine's energy to add pressure to the master cylinder. Anti-lock systems, originally developed for aircraft braking systems, use computer-controlled valves to limit the pressure delivered to each slave cylinder. If a wheel locks up, steering input cannot affect the car's direction. With ABS, no matter how hard the pedal is pressed, each wheel is prevented from locking up. This prevents skidding, and allows the driver to steer while panic braking. As impressive as these advances are, the basic process of converting a vehicle's momentum into heat energy has not changed since the days of the horse and buggy. To stop a horse-drawn carriage, the driver would pull on a lever which would rub on the wheel. But today, with the advent of regenerating brakes on electric vehicles, new ways of recapturing this lost energy are being developed. In these types of electric cars, when you step on the brakes, the motor switches into generator mode, and stores the car's momentum as chemical energy in the battery, to be used again when the light turns green.